The year is 2011. Physicists from around the world gather at a conference. They're there to celebrate the 100th birthday of quantum physics. This field explores the strange behavior of the universe at its smallest scales. But instead of cake and congratulations, there's a palpable tension in the air. The reason? A fundamental disagreement on what quantum mechanics actually means. A poll is taken at the conference. It asks these brilliant minds which interpretation of quantum mechanics they subscribe to. The results are shockingly diverse. No single interpretation garners a majority vote. It's clear, even a century after its inception, quantum mechanics remains an enigma. The very foundation of reality, it seems, is up for debate. This lack of consensus highlights a crucial point. Science, for all its objectivity, is not immune to interpretation. Just like religious scriptures inspire various denominations with differing beliefs, the book of nature can be read in multiple ways. Quantum mechanics, with its bizarre rules, pushes this to the extreme. So, what are these different interpretations that have the scientific world so divided? Let's dive in and explore these fascinating and often mind-boggling perspectives on the nature of reality. The Copenhagen Interpretation, named after the city where Niels Bohr and Werner Heisenberg hashed out its principles, is perhaps the most famous, or infamous, interpretation of quantum mechanics. It's also the one most likely to make your head spin. Why? Because it suggests that reality, at its fundamental level, is inherently probabilistic. Imagine a coin spinning in the air. Before it lands, it exists in a superposition, a state of being both heads and tails simultaneously. According to the Copenhagen Interpretation, quantum particles behave similarly. They exist in a haze of probability, their properties undefined until measured. It's the act of observation, the interaction with a measuring device, that collapses the wave function and forces the particle to choose a definite state. This interpretation leads to some truly bizarre conclusions. Does reality truly remain undefined until we, the observers, interact with it? Does the moon only exist when we look at it? The Copenhagen Interpretation seems to imply as much, challenging our intuitive understanding of a concrete, observer-independent reality. While widely taught, the Copenhagen Interpretation is not without its critics. Many physicists find its reliance on an observer-dependent reality unsatisfactory. It raises more questions than it answers. What constitutes an observer? Does it need to be conscious? These are questions that the Copenhagen Interpretation leaves frustratingly vague. If you find the Copenhagen Interpretation a bit too weird, you're not alone. Enter the many worlds interpretation, a mind-bending alternative proposed by physicist Hugh Everett III. This interpretation takes the idea of superposition to its most extreme conclusion. Remember that spinning coin? According to the many worlds interpretation, it doesn't actually collapse into one state or the other. Instead, the universe splits, creating a separate branch for each possible outcome. In one branch, the coin lands on heads. In another, it lands on tails. And so on for every quantum event that occurs. This means that every time you make a decision, every time a quantum particle goes left or right, a new universe is born. Each universe contains a different version of you, living out the consequences of that choice. It's a dizzying, even exhilarating thought. The many worlds interpretation elegantly sidesteps the observer problem of the Copenhagen Interpretation. Reality isn't dependent on an observer, it's constantly multiplying, creating a multiverse of infinite possibilities. However, the idea of countless, undetectable universes branching off at every moment strikes some as extravagant, even unfalsifiable. It's a theory that, while intriguing, remains firmly in the realm of speculation. If the Copenhagen Interpretation feels too observer-centric and the many worlds interpretation too extravagant, perhaps the consistent histories interpretation will appeal to your sense of narrative. Developed by physicist Robert Griffiths, this interpretation views quantum mechanics through the lens of storytelling. Imagine you're writing a history of your life. You can't include every single detail, every fleeting thought or insignificant action. Instead, you focus on key events, connecting them to create a coherent narrative. Consistent Histories approaches quantum mechanics in a similar way. Instead of focusing on individual particles and their uncertain states, Consistent Histories looks at the overall system. It identifies consistent histories, sequences of events that can be assigned probabilities. These histories are like different storylines, each offering a complete and self-contained account of how a quantum system evolved. The Consistent Histories interpretation avoids the pitfalls of both observer dependence and a multiplying multiverse. It emphasizes the importance of context and the interconnectedness of events. However, it also introduces a degree of ambiguity. Which histories are consistent, and which are not? The criteria for selection can seem somewhat arbitrary, leaving some physicists wanting for a more definitive framework.